Okay, we're going to set up for a panel right now, and this will happen in parallel to me chattering a little bit up here. So, good sign of maturity for how far we've come with seL4 is when I started a few years ago messing with seL4, my only choice back then, and this was in the dark ages, was do it by scratch, or I found this other thing called Gnode. And we got Gnode running and our business logic on there for medical devices on top of that. And it was pretty excruciating. And CAM keys came along, things got much better. But now we have 4 different organizations with OSs on seL4. And that's not even the entire community of the OS developers on seL4. There's other ones in addition to these 4. This is really cool because I'm coming at it from the critical infrastructure, the DoD side, medical devices, where I'm trying to make it easier for the real world to go develop secure applications, safe applications. It's not just about classical security. It's about building real systems that are important, that perform real missions, and they're actually there. They're robust. They're usable. But working in industry, we don't always have the same type of people that we have in here. We're in a rarefied atmosphere, okay? It has to be usable. We have to have options. There has to be longevity. It needs to look mature for them to start pick it up. And we're seeing that now. We have OSs. So I'm honored to facilitate this panel. If we can get the folks up here, they're supposed to be here. I don't know why they're not. And this looks like okay, I can do this. Nah, I'll stand. So we have Kent, Sid, Juliana, and Gernot. Okay? And so, well, unfortunately, they Oh, no, I have a chair. I just didn't have a Okay, when the music stops or the person babbling stops, you all have to have a chair, and we're going to start yanking these out of the way here. Really? So I have a bunch of questions prepared, but the program committee actually prepared the very first question for everybody, which is for each of you. Please present your views on the priorities and vision for your OS on seL4. Be complete. Remember, this is for posterity. But the downside is you each have only 1 minute to be concise about it. 1 minute. That's a challenge. So the order that we're going to go is left to right. No, no, we wanted concise, so it's.
I need to get my stopwatch ready. Right, well, at Cry10, our mission is to enable others to build and run the devices that the world relies on. And there's a lot in there to unpack, but there's essentially a few key directions or properties that principles that we try to follow following that. And so the first one is, of course, a secure, reliable foundation built on top of a verified microkernel. An architecture on top using a principle of least authority, componentized architecture. Moving on to enabling others, sorry, I made notes, but 1 minute is so much harder than 2 minutes or more. The other one is remote control. And I think that's one of the things that, apart from Gapfruit, set us apart from the other end of the spectrum, where real world devices that are built and run are developed iteratively, and they're controlled remotely often, and being able to do that in a reliable foundational way kind of relies on building a very, very strong core. And that's sort of the main thing that we're doing. The last one is enabling others. And so enabling others to be experts in their domain without having to be experts in seL4. And so we want to embrace existing tool chains and ways people do things rather than trying to build everything again from scratch.
Okay, thank you. Sid.
All right. From my perspective, I have different hats on. I have a business hat on, a systems architect hat on, and an engineering hat on. And from the business perspective, I need to respond to business needs from my clients as fast as possible. Now, as a systems architect, I need to respond to my business folks and to create an architecture where I can respond to those needs also as quick as possible, but I want to be able to improve the critical components in the system over time, and as you also mentioned, iteratively. And from an engineering's perspective, I think there is nothing better than formal methods when it comes to arguing about the quality aspects of a component. That's a powerful feature. But there is another powerful concept, which is more on how components interact with each other. And if you do that right, you get a trust graph where you can identify the critical components and then use tools such as formal verification or others to improve those subsystems.
Excellent. Thank you, Sid. Juliana.
I appreciate the offer of a mic. I was apparently mic'd, so we're good. Yes, so from the perspective of Magnetite, what we're looking at is being able to support a variety of embedded devices that have security critical needs, things like infrastructure, UAVs, satellites, some of the examples that I mentioned during my presentation earlier. And that's why seL4 actually provided a very solid foundation for the work that we were doing and its isolation properties. We tried to extend that with some of the features that we added, the creation of silos, having features separated into separate processes, and a minimization of functionality for each of our services by grouping requests, like API requests, by the kinds of resources that they would deal with. And we want to continue going in that direction. It's our hope now that we have a pretty featureful set of services to start being able to apply that more at the application layer, to be able to get some more of those examples, some more macro benchmarks like Gernot mentioned earlier, and to continue to offer this featureful API that we may extend in both Rust and C. So we have support for legacy applications as well as newer applications written in Rust. And that means abstracting seL4 away to some extent from the end user as well. So they can get the benefits of it, but still use a POSIX-like API so that the adoption should be a little bit easier process.
Thank you, Juliana. Gernot.
Okay, I listed my priorities yesterday already. It's fast, secure, adaptable. And because it's built on the microkit, it's also easy to use because that's the whole design idea behind the microkit. So fastest microkernel-based OS ever, secure, most secure OS ever, adaptable. We don't give you a shrink-wrapped OS. We give you an OS with template implementation that work for one or few specific use cases. They're trivial to adapt to your use case. And ideally, there's no guarantee, but ideally, if you rewrite one of these components for your use case specific policy, then the push button verification will still go through. Again, this needs to be seen, but for if the changes are not too big and they shouldn't really affect the functional properties, then there's a reasonable chance this will happen.
Excellent. Well, thank you for that. Now, the 1 minute, that was an interesting thing because if you notice, none of them quite managed the 1 minute. So from a real-time panel perspective, we might have some concerns there. It's related to this next question. For what is your OS optimized? So multiple dimensions could be interesting to folks. Is it optimized for different domains like IoT, automotive, entertainment systems, web browsers, that type of stuff? Or is it optimized for ease of use, predictability, dependability, real time, no side channels, confidentiality. So brief answers, if you can pick out like top 3 to 5, 20 things for which it's optimized. And we're going to go the other direction to spin things up a little bit. So Gernot, I mean, you already kind of told us the properties, but still go for it.
Okay, it's, as I said, it's not a shrink wrap thing. It's adaptable and it's optimizable for any of these use cases. And real time is an interesting point. Obviously, we have a bit of experience in real-time properties. This is something I actually want to restart to push up worst-case execution time guarantees about meeting deadlines into the operating system layer. That's going to be a second step, though.
Thank you. Juliana?
All right. Security and performance are really of list up there, our primary objectives here. I already mentioned that we're looking a lot at embedded devices that have critical security needs, though it could be more broadly applicable. Let's see. I would say the application of least privilege, being able to reason about data flow, and isolation properties are ones that we find very important and want to continue to maintain.
Cool. Thanks. Sid?
That's a hard question. I'm wondering which hat I should take on. So from a business perspective, we chose the industrial IoT field because that's where I see the longest hanging fruits for the most benefit that we can get. And the security industry has a little bit of a problem of selling, right? So you're selling kind of vitamins compared to painkillers, and we want to focus on selling painkillers. And so with the industrial IoT, we can actually quantify the amount of how much it costs when it comes to downtimes, and also how fast we can deploy new applications and how that development process is. However, in the long run, I see the most benefit in the combination of safety critical and security, as you can't get you can only get safety when it's secure. And that's quite a challenge because we have different domains having different engineering philosophies behind it. And I think, and I truly believe that these concepts of microkernel and the strong separation and the control over dependencies kind of is the optimal solution for that clash of engineering fields. So
Nice. You had me cheering there from all the different domains I work with. So yeah, nice. Kent?
All right, well, on the device side, we're largely optimized for, as everyone else is on this panel, embedded real-world devices that don't typically have someone sitting in front of it managing it. It's potentially up on a pole somewhere or embedded in a factory, and the cost of it failing is a lot more expensive than the value of the device itself. So it's critical. So that's sort of what we're, very vague answer for what we're optimizing for on the device side. For the developer side, so these are people building devices, we're currently optimizing for beginner experts. And by this I mean they're experts at building embedded devices, but they're beginners with seL4, or they might not have even heard about seL4. And so sort of trying to level them up to be able to leverage and build on top of these attributes or these new like Lego bricks that exist in a verified, componentized, object capability-based system, while still being able to build the stuff that they know a lot of domain knowledge about. And then on the operator and the deployment side, we are optimized towards like what we call deployment owners, who may be responsible for managing the device. They may even own the device, but they may not. They may have to rely on a large network of inputs and suppliers to actually build up and make sure that that device is running and operating properly. And so they need to know that all of the different inputs, whether they're software inputs or their hardware inputs, are that they can depend on them, that they can rely that it hasn't been changed, so that when they are deploying the software and their devices out in the field, they can do that with confidence. And that they can also, of course, change it remotely.
Excellent. I like that emphasis on the beginners, because most of industry out there from a safety security perspective, they really are still beginners. They're good at the functions, and Agile encourages that. Let's do the function with the absence of any actual quality. So yay for that. So that's exciting to hear. So I have a bunch more questions lined up, but this is actually for all of the rest of you as well. So who has a question that they want to ask of the panel? The more divisive, different answers you're going to get, the better. Going once, going twice. Oh, okay.
So there were a lot of different priorities, and everyone listed a whole bunch of them as well. Priority kind of means which one's the most important. So of all the things you've all listed, which is the one you're tackling first? Which is the most important one? Just one. Each.
Okay, we're going to go inside out, so we'll start with Juliana, Sid, Gernot, Kent.
Okay. Isolation. If I had to pick one word.
Is that?
Painkillers.
Yeah, I'm sorry. With Lines OS, you have to take all three.
Which one are you going to work on first?
We're working on all three of them in parallel, and I'm honest about this. But okay, Kent.
This is a hard question. I'm going to say getting the bits to flow, which someone said to me when they're like, I just want the device drivers that can get the bits flowing from one end of my device to the other end of the device. And if I can't do that, then it doesn't matter what operating system I use if I can't do the function that I need to do.
That is a useful thing. Thank you. Okay, question over here.
Those are long words you guys have.
Was it one word?
One priority.
So yes, on majority of presentation, I see presenters comparing themselves with the various version of Linux. How would you compare yourself with the commercial versions of microkernels, such as Integrity, for example, Green Hill?
So it's difficult to do because you can't even get their spec unless you have an NDA. What I know from various indirect sources is all these commercial things, as if seL4 was not commercial, but all these commercial things have one thing in common: they're at least a factor of 10 slower than seL4. But of course, they have, to balance that, they have a very mature system that gives you services, etc. And often they have certifications, etc. Of course, they don't have verification either, but they at least have some certification stamps. And this is where we as a community are still catching up. But I don't think we are actually far away, because we really have seen a lot of discussion on operating system at a maturity which honestly I would have a year ago not dreamt about. So in that sense, the community has really made a huge jump forward. And if I may, just want to make one more comment. One question here, and this is why we're getting really diverse kind of answers, is what the hell is an operating system? On a microkernel, that's actually ill-defined. You can't really have a clear boundary between operating system and application level, because it's all processes running on top of seL4.
Thank you. We have another question back here.
Hi there. For the projects which are not open sourced, is there a plan to open source a limited version so that academics could play with it to do research on top of it? or some kind of academic licensing?
Yes.
Yeah, I can add to that with a similar response. Yes, we do want at some point to be able to open source Magnetite. Our initial visibility of it is more in collaborations with our sponsors, and we've been happy to work with people and organizations in that method up until now. But being able to introduce it to the community is definitely a hope that we have, and it's more about having a path forward for that. I would say, I could see that in the future. Yeah.
I guess so far we've been with our with partners that we work with, we've been source available, and so they've had access to the source. I haven't been prepared on how to comment about whether we'll ever be fully open source or partially open source. I think there's a distinction between source available and like open source implies that we take contributions from the community. And so that's like not something that we're currently prioritizing. That being said, like by using seL4, one of the foundational pieces that's enabling the technology is open source, and we do try to push back like contributions there and support the community, because like at the moment seL4 is still quite a small community, and like all of us are going to be successful if seL4 is successful. Maybe I got that around the wrong way. Like the impact that seL4 can have is can be a lot bigger if it's successful.
Excellent, thank you. So let's move on to the next question.
There we go. I wanted to follow up a bit on what Gernot last said. I'm of two minds about POSIX. On the one hand, I think seL4 is revolutionary, and it can enable further revolutionary thought in operating systems development. At the same time, we've got this iron ball called Unix that we've been dragging for 50 years. By sticking a POSIX, and so on the one hand, I feel, okay, if we stick a POSIX layer on top of this thing, it's going to be the Linux kernel all over again, where we don't really do anything revolutionary apart from its development approach, the whole open source thing. And on the other hand, if we don't do that, are we going to stay in rooms as small as this for the foreseeable future? And I'd like to know which side of that dichotomy the panelists come down on, or if they can perform some kind of Hegelian synthesis.
Yeah, I disagree with your basic premise here. I get the question a lot, will it support POSIX? And my general answer is no one needs POSIX. What people want is a POSIX-like I/O API, and that's pretty much it. This is trivial to wrap around. You probably cop an extra data copy. We already saw that we can slip an extra data copy in and are still twice as fast as Linux, so not worry about that.
Yeah, I think Magnetite also really lives in that in-between space with POSIX-like, because our API was designed to be familiar enough for developers so that when we get to the point of adding applications on top of it, it's going to be familiar, but not make all of the same mistakes or bring on that same weight that is introduced by full POSIX. So it's similar in the kinds of arguments and the kinds of calls you can make, but it's not just a copy pasta of everything that is POSIX.
So my answer is more in the line of Gnode, how the Gnode framework does that. And I'm not affiliated with Gnode, but when you specify a component, you also specify their dependencies. So a security critical component, you try to keep the TCP as low as possible. And that means that you don't want any libc, you don't want any POSIX, you don't even want any standard C++ library in there. And And the Gnode framework enables you that to define, all right, this component is going to need to benefit from legacy code. However, this other component that so many other components depend on, let's keep the TCP as low as possible. So you try to design that in a way that enables this, and to make it small and reason about the quality of that component.
I was just going to have one thing to add, which is that hardware has already given us the backwards compatibility POSIX support through the virtualization extensions, like where you can put it in a VM if you need to. But I think it's like a lot of software has been written in the world, and a lot more software is going to be written, and it's going to be written against POSIX. And so there's, yeah, and so it's not going anywhere, and it's the world we live in. And a lot of people need to use it to do their jobs, and so we should be able to have a way to at least allow them to be successful.
Just following up on that, I mean, there's another aspect to POSIX, which is not just porting applications, but also supporting runtimes. So people expect lots of different kind of language runtimes and so on that are mostly implemented and mostly assume POSIX underneath them. So it's not just sticking things in a VM, but if you want to have like a native kind of first-class runtime, then you have to deal with the POSIX question at some point as well.
Okay, earlier on, Gerwin mentioned an unpleasant word, which I think is important, and that is certification. There are a lot of industries where, unless something is certified, it's unfortunately not going to be used, however much that industry is crying out for the sort of possibilities that seL4 can offer. I just wondered what everybody on the panel thinks about certification, even though we perhaps would prefer not to think about it. It's necessary.
I think I can pick up on where Gernot was kind of left off. Without stating any names, I think those companies that have or built microkernel-ish or old school microkernel operating systems, they are in the benefit that they have this huge cash cow, and they have also these business models that are almost forgotten, with developer seats that cost like 50,000 a year. So, and I think there is a huge opportunity for this community to kind of go into that field, because with controlling the TCP and keeping that as low as possible, the certification costs is also lower. Yeah.
So my comment on certification is mostly that the biggest pain from certification is that it's way behind the state of the art. All these certification regimes, with one major exception, are really trying to they're glorified ISO 9000 processes where you have huge loads of documentation to provide, which is all irrelevant when you have formal proofs. Fortunately, avionics is showing the way there, I think, where we now have the, I think, DO333 standard, and I think our friend Darren, who is busy reading email, has his fingers in that one. Good, thanks, Darren. Which basically allows you to replace a lot of this old shit, but with proper formal evidence. So obviously we can't wait until everyone catches up, particularly automotive, which who still thinks if you're MISRA compliant, then you're fine, and would force us to rewrite our kernel because it's not MISRA compliant. Ridiculous things like that. This is from my point of view, okay. It will be needed. People will have to go through it. It's expensive. This needs to be driven by commercial interests, obviously, and need to tackle it as we go. But hopefully, for example, when we go through have systems that are DO333 certified, that this will have some weight in other domains that have much lesser standards.
So I have a follow-up in this area. One of the systems I did in the past, it was seL4 at the bottom, but there was no OS framework in the middle, and I had formally verified apps on top of it, and I got chewed out by this community because there's this gap in the middle that I was relying on. So for your OSs, what's your approach for formal what's your verification approach? So, because the OS has to be verified. I can't just have this soup in the middle, even if it's written by just brilliant people. So I'm not sure the order, so how about you volunteer where you want to jump in?
So I think first things first, we build on top of the verified version of seL4, which unfortunately means we can't utilize the MCS mechanisms at this stage because we use the verified version that's ARMv7 or RISC-V64. Then moving up, the next thing we do is we whack on a dynamic supervisor on top, which has a lot of power in the system. And so we're working on a way for verifying correct properties of that. And architecturally, we choose to have minimal, like the option, like Sid was saying, like similarly, specifying the ability for a component to specify the sort of runtime environment it expects, which allows you to define like critical components that don't take any sort of dependencies, and they just are a protection domain blob of seL4 code, well, not seL4 code, blob of like low-level code that can be as small or as simple as it needs to be. And then you can bring your own verification methods, use safety languages like Rust. For some of our components that we rely on, in some cases, we've used TLA to sort of try to do some rough specification of the design and testing more of the, like refining that design and checking that like the executable design makes sense. And in other cases, using off-the-shelf components that like huge numbers of things in the industry rely on. And that's not verification, but it's increasing assurance through copying other people, I guess.
But that's understandable. In the real world, you can't necessarily formally verify everything, so you have to make use of what's available. So, next.
Yeah, so in terms of formal verification, we intentionally designed our system so that we would be able to minimize the overlap in functionality, to be able to ensure that you could, at configuration time, actually specify what you want your architecture to look like, meaning what silos you want to start up, which are completely independent of resources and capabilities and caches, etc. And then even within those silos, to be able to determine what services you need, if you need duplicates of them, if you don't want them to share the same exact resource IDs, and to have isolation within or between each process, all because we're building on top of seL4 and trying to bring that into the next step for isolation. So a lot of that was designed so that we could, as I mentioned a couple of times, reason about data flow. And I think that's quite important because even if you can't formally verify every part of an operating system, if you have a sense about where data is actually going, what paths it can take and what paths it can't, then you have greater confidence about what it will actually be able to execute and what it will be doing. That's not to say we aren't considering any form of formal verification for parts of the operating system, but in its entirety is not in scope at this point.
Thank you. I like that. And I like bringing up Gage's spectrum from yesterday. That's a good way to look at it.
I think I gave my answer mostly yesterday already. The OS is designed for verification. Radical simplicity means everything is as easy as it can be and should enable verification. We will verify some significant parts of it, and going back to my previous comment, I can claim that we will verify the OS because the verified bits are going to be the OS. But just clarify a bit further. So we are striving for a complete story that connects the verified OS components with the seL4 proofs. And again, this is exploratory at this stage, so I can't really make any guarantees. And yes, we will have to carry non-MCS along with us to make sure that we have this connection to a verified version of the kernel at least as soon as the 64-bit verification is completed in about half a year's time.
Please keep working on the MCS, though. Really? Please.
I fully sympathize.
So our systems architecture is designed to respond to business needs. And if the business needs us to spend more time in focusing the quality assurance of a particular subsystem, then we will do so. And this can be done by like if if our customer requires us to certify, or if they want to build a product that is certified or must be certified, then we will address things. And if formal methods are a way to enable easier certification, then we will do so. And I also want to point out from the certification process, it often means that it's not really the operating system that you're certifying; it's the product as a whole. So the physical thing that you're selling, and so we have to, and we're not building hardware, so we have to work closely together with hardware vendors to respond to their business needs.
Okay, thank you. June?
Yes, I had a question regarding timeline of availability and maturity. So if I'm a company that wants to build my next product on seL4 and need an operating system or operating system framework, can each of you tell me when would you recommend that your OS or OS framework is ready to be used and shipped in my product?
Well, again, I given the answer yesterday. There will be a mature release with limited functionality, but mature and well documented, March next year, which happens to be the time when the AR64 verification is supposed to be finished, and some degree of verification later next year.
As far as Magnetite goes, we have a full implementation of all of the elements, services, features listed in green from the presentation earlier, which I'll try to make available to everyone. So it is mature, and that's not to say we won't continue to add features, but I think it would realistically be shippable. It's more a matter of finding a path forward to actually potentially make that available to the broader community at this point. That's more of what we'd have to explore.
You specifically mentioned seL4. Well, our products use a different microkernel as we speak, so we're already in the banking industry running on HSMs. And in the industrial field, we're having multiple projects going on with the IoT gateway that I showed in my presentation, which is an IMX8 64-bit, which so we're in projects which tend to be very long. So yeah, we're in this phase. When it comes to seL4, as I mentioned before, this is something that we will address in the future.
I think yesterday in Boyd's talk, he sort of threw up some numbers saying that we'll be having a release in November, and which is a minor release, and a major release next year in June 2024 next year. and like today, right now, like we have release candidates available that we are like working with early partners on. And so like if people are interested, then they can get in touch with us. And because like we're sort of at that stage where we're absorbing early feedback and like working with early partners on like getting like case studies and examples ready for like demonstrating confidence that it works and is usable.
Okay, thank you. David.
So as people who are providing value on top of seL4, I'm curious to know what would be the one seL4 feature you would like to change to make your jobs easier?
No. I have a whole list of things I would like to change. The number one is obviously the RFC I talked about yesterday, having the threshold for endpoints connecting to passive servers to simplify the design of passive servers. And then there's a few other things, like the way mappings are done that requires you to have more system calls than necessary. But we need more performance analysis to justify those.
I don't know if this is a modification so much as that probably like many of us on this panel, we're looking forward to seeing MCS formally verified so that we can introduce that into as the version that we switch over into our code base. Not that there's anything wrong with standard seL4, it's quite strong, but we would like to be able to see what we could do in that direction.
For me, is the combination of the GNOB framework and seL4. There is improvements.
The amount of funding that the seL4 Foundation gets, I think one of the biggest challenges is there's a lot of people have a lot of needs, and like a lot of work goes into the verification. So I guess if the other thing I could change concretely, it would be the amount of effort that had to go into verification, if that was a lot smaller. Being even more concrete, probably like multi-core, like being able to access all of the hardware functionality on the platforms that we want to run on. But I'm changing that.
Okay, thank you. Lucy?
Okay, we've talked a lot about security, but there are often performance requirements in real-world systems. Can you all comment on what you're doing to optimize performance? I don't need to hear from Gernot.
In Australia, we call this a Dorothy Dixer.
All right. Let's see, to optimize performance. So I'll start off by saying that one of our major use cases that we've been looking at from the beginning is embedded systems with security critical applications and real-time requirements. So that's been on our mind from the beginning. And part of that has been to design with an intentionality to, say, minimize extra layers of calls, try to ensure that we have some of the setup, for example, not on the fast path, trying to make sure that that fast path is indeed fast for the kind of calls that you need to make. And part of it, too, is iteration. I mean, I think we learn from doing with our architecture in designing something that we can then see where there might be bottlenecks and then iterating that in improvement. And that's just part of the software design lifecycle as well. But we definitely have, every time we introduce new features or a new version, we run through our benchmarks and ensure that those micro benchmarks and performance still hold. And I can actually see more room for improvement in performance in some of those areas if we continue to optimize. It's certainly not a journey that is complete yet.
Well, we also approach performance things or requirements from the business needs, but it's it's something that is also falls in the line of identifying the critical components, because performance is a quality attribute, as confidentiality or availability. And by being able to identify those components, we can make them faster. I'm not sure if I've answered that question, but this is how we approach these things.
I think one thing I learned from Gernot was the importance of measuring things and understanding why things cost what they cost. And from there you can see whether or not things can be made faster, or and then it's choice whether or not you want to invest in making them faster, and that's business needs. I think at the moment for us, the greatest performance bottleneck is the fact that all but one of the cores are currently inaccessible. And that's what we're currently trying to prioritize resolving.
Okay, thank you, everybody. Thank you for the questions, and thank you to the panel.